Bismillah. Hello everyone and welcome to my today's lecture on projectile motion. Today we are going to study the projectile motion, the formula related to it and how we can solve it. So before it we will have some understanding of it. Okay. So let's define what is a projectile motion. We can say that a projectile is any object that is thrown or dropped or otherwise launched into the air, okay, and it is subject to the gravity. So let's see example here. I will make an x and y axis here, okay. This is x, this is y, this is x, and this is y, okay. And suppose I throw a ball into the air, so it goes up, and after reaching a maximum point it will drop on the surface, okay. So what is important here that this object has only one influential force and the gravitational acceleration is always working, okay. So there is no influence apart from the gravity, okay. And in this type of problems we generally in books or in class lecture we have certain assumptions, okay. So let's talk about some assumptions, okay. I will write here assumptions, okay. The first assumption is we ignore aerodynamic drag, okay. We, because of the air there is some certain resistance, okay. So we generally ignore this in our calculation. Second is that curvature of the earth, okay. Curvature of earth, it means that you know that earth is not a flat, it's a certain curvature. So suppose your one rocket is launched from here, it goes up into the sky and then it will come back to the earth. So this curvature, we assume that this is a flat, this is a straight line, okay. Thirdly, we ignore rotation of earth, okay. So in this case we do not assume that earth is rotating. And we have one more assumption, that we assume that there is a constant acceleration, okay. Constant acceleration is the acceleration in x direction is 0 and acceleration in the y direction is minus g, okay. So before we proceed, let's talk about some fundamentals, okay. So I will talk about the projectile motion. So when we throw certain thing into the sky, you see that it goes up, it reaches to the maximum point, we can say this is maximum height, okay, and then it goes back to the surface, okay. So here you can see that this motion is not a perfect circle or semicircle, okay. Like for example, if I will say this is a circle, okay, and this is a half semicircle, so this projectile motion is not a semicircle, okay, is not a semicircle, it's a curvilinear path, and the one segment have the like this segment of curvilinear path will have another center, this will have another center, and likewise, okay. So this is the difference between the semicircle and the projectile motion, okay. Now let's move to the another concept here, that when certain things, like when you throw a ball, it goes up, it means that velocity is decreasing. For example, if you there is a ball in your hand and you throw into the air, okay, it goes up and it stops here and then it returns back, okay. What you observe here, that when you throw a ball up, it the velocity is decreasing up to maximum height, the velocity will be 0. So we can say that velocity component at this point is 0. Okay, and then it reverses back and then velocity increases. Similarly, we can see in the projectile motion that here when we throw a ball, it goes up to the maximum point, maximum height. Okay, the velocity is decreasing. Okay, and it becomes 0, the y component, and then it increases again. So now we are talking about the velocity. Why not we make a component of it? Okay, suppose we have been given the initial velocity, initial speed of projectile is 50 meter per second. Okay, so you can see this vector speed, sorry. So we can make a component of it. Okay, and we can say that for this vector Vx, velocity in x direction, is V naught cos theta. Okay, there will be angle of launch. Okay, and Vy will be V naught sine theta. So here you can say that this is Vx and this is our Vy. Okay, now there is another concept, and very important concept is here, that Vx is always constant. You will find the same everywhere. If you find, if you calculate Vx, it will be same here, same here, same here. At each point Vx will be the same. Okay, but Vy will keep changing at each position. Okay, so Vy is higher, decreases, and at the maximum point the Vy will be 0. So Vy will be 0 at what position? Maximum height. Okay, so at this max height Vy will be 0, but remember Vx will be not 0 at the maximum height. Okay, now guys, let's talk about how to draw velocity vectors. Okay, in this case, in the projectile motion, so we have x and y direction, and this is the projectile motion. And if I will ask you, uh, make a projectile, this projectile velocity vector at this point, and this is the height maximum height it reached. Okay, so at this point you know that Vx will be like this and Vy will be in upward direction. Okay, what about at the maximum height? As you know that Vy will be 0, so we can have only Vx vector. Okay, and what is Vx? As I said, Vx is V naught cos theta. V naught is initial velocity. Okay, speed. Okay, anyway, so at this point if I will ask you what will be the velocity vectors at this point, so you can make Vx as the same, but you know that it's dropping down. Okay, so the direction will change and Vy will be in the downward direction, right? Okay, now let's talk about how we can solve problem. Okay, so basically we have certain launch conditions are given. Okay, so I will write launch conditions are generally given into the exams or problems. Initial or launch speed is given, v naught is certain time given. Okay, launch angle theta is sometime it is given. Okay, and we have to also put the coordinates, suitable coordinate. Okay, so we have to find, for example, I will take example, this is a guy who is throwing a ball. Okay, okay, he has a ball in hand and it goes up and it lands at certain place. Okay, so to solve this problem you have to find a suitable coordinate. Okay, and generally we use x and y. Now you can see that the launch is at from this point, so you can choose x and y from this. Okay, and for this position you can choose the another depth here. Okay, so I will show you in another example now. Okay, but before we solve this, let's go to some formula which is very important in our calculation. Okay, so first of all, as you know that we can find x component. Okay, we can write vo cos v naught cos theta. Okay, then we can write vy v naught sine theta. Theta is angle of launch. Okay, apart from these equation we have another equation. Okay, we can write vy is equal to vy naught, okay, minus g multiplied by time. Okay, and in certain cases we have to calculate how far this ball will be launched or it will drop. Okay, how far it is going in x direction. Okay, sometime question will ask you at t time what will be the height of the ball or projectile. So in this case we can use formula for x and y. Okay, so I will write for x, it is x naught plus v x naught multiplied by time. Okay, so you can find the range of based on the time. Similarly you can also find the y height, that height in the y direction, using y naught plus vy naught multiplied by time minus half gta square. Okay, this can be used for y direction calculation. Okay, now we have a very important formula. Okay, and that is about the velocity of y. Okay, the component y component vy square is equal to vy naught square minus 2g y minus y naught. Okay, now guys look here, if you have these values, for example, if you have height is given. Okay, the initial height is given and then you have the height and the projectile height is given, then you can find the velocity at that point. Okay, suppose in this figure I will come back. Okay, and at this position if we have given, if we have a y value, okay, is given to us. Okay, and if we have y naught is 0, suppose, okay, or certain values, this is also given, and if we know the initial velocity, okay, then we can find what will be the vy at this position. Now there is something interesting about this formula. You know that at maximum height, of the projectile, okay, vy is equal to 0. So you can utilize this formula to find the maximum height. How? You will make this vy is equal to 0 and then you will put the values of initial velocity and the initial height. Okay, then you can calculate this y. Okay, so this is one of the important formula in projectile motion. Okay, and we have a certain very important uh, concept here. Okay, one of the most important principle in this projectile motion, we say that horizontal and vertical motions are independent of each other. Okay, the x motion and the y motions are completely independent. This means that horizontal motion does not affect the vertical motion, vice versa. Okay, so you have already seen these are the formula we use, okay, for the projectile motion. Okay, if you remember this, you can easily calculate. Okay, sometime we do mistake. Okay, so what are the common mistakes? I will write common mistakes. Okay, when we are solving problem, we do mistakes. First of all, we have to take care about the initial speed. This is initial speed. If we are calculating Vx, write V naught cos theta. Sometimes student directly use V naught. Okay, when you are have to use in this formula Vy, write the value V naught sin theta. Okay, so make sure you are using right component. Okay, secondly, sometimes we forget about Vx. Okay, that Vx is always constant. Okay, it's not changing with respect to time or with respect to um, location of the flight or projectile. Okay guys, so let's see what are the some common type of problems we have to calculate. Okay, sometime we will be given v naught initial speed and the theta is given, so you have to calculate maybe time of flight. Okay, maybe you have to calculate how much far it will go in x direction. Okay, or where it will drop, find the coordinate x and y. Okay, and we have also some problems vice versa, in which case we have to find initial speed or we have to find theta. Okay, now let's see one more formula which is also important. Okay, and to for a normal projectile motion, okay, we can find the range of flight. Okay, range of flight, how far maximum it will fly. Okay, given that we have initial speed and the angle is given to us. For example, this is x and y, and this is our initial speed is given with this respect to theta. So how far this projectile will land. So in that case we use a formula of range. Okay, r is equal to v naught square multiplied by sine 2 theta upon g. Okay, so this simplify our problem.